Very quickly in this video we're going to cover the basic premises of parallel and perpendicular lines, and it all goes back to slope essentially. Okay, so when we talk about parallel lines, let's go ahead and start by considering what parallel lines are. Let's say we were to graph two parallel lines right here. These are lines that if you want to talk about slope, have the same steepness, kind of thing going on. Also this, we would say these are two lines that by definition never intersect. So basically we could say, well, what must be true about the slope of parallel lines? Well, when we discuss slope, we use the letter m, and again, recall that we define it as rise over run. So when comparing the rise over run of two lines that have the same steepness, what we can necessarily say is this: they must have equal slopes. So let us refer to this as line 1, and we'll refer to this as line 2, and we will say that line 1 has a slope of m1, and we will say that line 2 has a slope of m2. We say that two lines that are parallel must have the same slopes. So that's what's true about parallel lines. Let's talk about perpendicular. Now, interesting. Let's say I actually come up with a line, and I know this is really small grid, but we'll say 0, 0. We'll go up 1, 2, 3, 4, 5, and over 2. Up 4 over 2. This is a line that has a slope of 2-ish, but we're just going to call this line 1. What I wanted us to see, though, essentially is this: if I wanted a line that was perpendicular to this, when we say that this is got a slope of approximately 2-ish. Okay, rise over run of rises 2, runs 1. Essentially, what would I want to make the slope of its perpendicular line? A lot of people say a lot of the time, well, wouldn't I want to make m2, this slope of the second line, equal to -2? And what I want you to see is, if I were to go, like, say, down to right 1 from here, I say it look like that. Okay, and so what I can tell you is that's not necessarily perpendicular. What we need to do is this, and I'm just going to come out and tell us what the deal is here. When it comes to perpendicular slopes, what we want are negative reciprocals. So if this is the slope of my first line here, what I want to be true about my second line is that slope subscript 2 would have to be the reciprocal of this and opposite. So if I were to go, say, down 1, right 2, down 1, right 2, here, something like that, then I would have this other line, L2, that has a perpendicular slope, that is, meets this at a right angle. So here's the deal with perpendicular slopes. We say, given that I have two lines, L1 and L2, we say the slope of the first line would be the negative reciprocal of the slope of the second line. Okay, and this is also true. We could say also, this is kind of a weird fact. We say the slope of the second line then is the negative reciprocal of the slope of the first line. All you need to know essentially is this, is that they are opposite reciprocals. This is your rule. So opposite reciprocals. So when we talk about these graphs now, let's take a look at this real quick set of examples I have down. It says, tell whether the lines through the following sets of points are parallel, perpendicular, neither, and if they're not parallel, tell which one is steeper. Okay, so when I look at these, we say I've got a couple of lines here, and I'm saying the points that they go through. So here's one thing that I like to do, and it's just kind of sketch out a diagram of the situation. So this first one here, it says -3, 3. If I were to go left 3 and up 3, -3, 3, that would be this point right here. We should probably do it in a different color. We say -3, 3, and then we say 3, 1. So if I were to go right 3, and it's -1 actually, so 3, -1. The first thing I see is that I've got a line that goes downhill. So this one has definitely got a negative slope on my line 1. We'll call this line 1. That's this guy. We say line 2 through -2, -3. So if I were to go left 2 and down 3, I'm drawing this by hand, so it's just a rough sketch. We could still probably get a good idea about this stuff. And we say, all right, so 2, 3. If I were to go right 2 and up 3, it'd be here. Okay, so we say 2, 3. So I'll go ahead and sketch this in here. And so just by looking at this, we say line 2's got to have a positive slope, line 1's negative. Maybe they're perpendicular. So I'm going to draw this in. I'm going to put a big fat question mark right there. What we're going to do is we're actually going to find the slope of these lines. Now, of course, what we could do is we could count rise over run. We have the graph here, but since I don't have grid paper, I don't really trust my numbers very well. So for line 1 here, we're going to say it has slope 1. We're going to use the slope formula. And recall that the slope formula, since it's change in y over change in x, rise over run, we say is y2 minus y1 over x2 minus x1, where, say x1, y1 is just our first point, and x2, y2 is just our second point. Okay, so we're going to do this for both lines really quickly here. We say 3, or y2 here would be -1, and y1 is 3. And we say down here, we say 3 is our x2, and our x1 is -3. So when we go ahead and find this comparison here, we say -4 compared to, it says 3 plus a positive 3 would be a 6, so we get this negative 2/3. Now, this is the slope of the first line. When we go and do this with the second line, this is m2. We're going to get rise over run, change in y over change in x. So in this case, we get y2 is 3, y1 is negative 3. And we get 2, so our x2, negative 2 is our x1. So we get this 3 plus a positive 3 on top. And in the basement, we get 2 plus a positive 2, so I get 6, 4. That's a 4. So a 4. And we say 3/2. And so what I want to do is I want to compare these. And when I compare, what I want you to notice is this, is that they're opposite of one another in sign, and they're also reciprocated. So opposite reciprocals. Okay. So the thing we're going to draw from this is basically, we can identify that just by knowing the definition of parallel perpendicular. This last one here, I would challenge you to do that one on your own, but if they're parallel, they're going to have the same slopes, and if they don't come out parallel, which one is steeper is going to be the one that does the more rising or falling. So cheers.